So topic will be sustainability and green manufacturing in industrial 4.0 scenarios. So basically, when we, this quote is something which I like the most. This says that the speed of change has never been this fast, yet it will never be this slow again. So what it means? It means that change is inevitable. Change is the only constant, they say. But another thing which this quotation says, that the rate of change. So the rate of change is also changing with the time. For example, our first industrial revolution, it took maybe 70-75 years to restore industry 2.0. But then if we see now, 3 to 4 transition is almost in 20-25 years. So that means rate of change is also changing, and that is something which we have to keep. And as an engineer, we should try to capture this, or at least in pace with these kind of scenarios. So this is, I think by now you must be knowing about this definition of sustainability. Okay, I need not to tell you, but this was something very good thought which came from whole globe people, right? So they wanted to, of course, all the resources are limited, okay, and then several agencies, several academicians, industrialists and organizations, they thought that we should think about something should be left for our younger generations or future generations, right? And that is from where this thought, so slightly in the last 80s of the last century, it came, and there was a formal meeting, and where they defined this sustainable development, and they call it that meeting the needs of present without compromising the ability of future generations to meet their own needs. It makes a lot of sense actually, because it's, I need not to say that, but we must know that we are using the resources in left and right, without thinking about our younger generation. For example, if we see the case of Punjab, right? So we are adjusting the water like anything, without worrying about what our grandchildren or maybe our great-grandchildren, what they are going to do, right? So that is something to be think about, and the only way to do is that we should set some kind of goals to meet this one, right? So what is so this is the beautiful, of course this is more academic, and I don't want to go in very academic things here. I want to keep it lighter as possible as I can, and please feel free to talk to me in between also. I have no fixed agenda. I have although more than 100 slides here, but I am not going to go through all these slides right now, right? So only few things we would like to touch. So academically, when we call sustainability, so in sustainability, what are the 3 pillars actually? So these 3 pillars are basically environmental, social and economic, right? So these 3 things you have to be worried about, okay? So environmental sustainability, that we should, this is nicely written here, that we should use the consumption, or the rate of consumption of the resources from the nature should be such that the replenishment, this should match to the rate of replenishment that Kudrat paida bhi kardi hai, right? So whatever it is being producing, our rate of use should not be more than that, okay? So it's like very like an engineer, that you can now think about that what should be our limit in terms of using these resources. Another important thing is that while we know that we will be creating some kind of garbage and pollution, and we also know that the nature can then heal it, right? So it can restore it. So that is another thing which you have to take care, that whatever pollution you are producing, that rate of production of that pollution should not go beyond the nature's capability to restore it, right? So beautifully, so this is one environmental issue which was ignored for years, and that's why we are at this point of time that we are facing this problem. And of course, social responsibility or social sustainability, basically we want to uphold the human rights, because every individual has the same right on this earth, right? So can we do something that all the people on this earth have the freedom to use the resources or exercise their freedom? But at this point, I want to tell you that freedom comes with responsibility, right? And that is where probably we have gone wrong, that we always say we are free country. Just I'm digressing from this, but I can't stop from saying that. But most of us, what we are doing, we say we are freedom, but we are not realizing our responsibility, right? So responsibility is that we should honor the freedom of others as well, right? So for example, if you have a right to stand in front of or on the edge of a road, the other guy has a kind of right to turn that road, and at that point you have to vacate that road, right? So if you're not doing that, you are not a responsible person, right? So same way, engineering things, resources. So whenever you are using resources, okay, so you should make sure that others can also use. It's not that you have the capacity and you will spend anything to capture the resources, store them, right? यही तो होता है ना अक्सर. So we store so many things, and at one point of time other people are getting died with hunger, but at other points we have a lot of say food and other items. So that is another thing which comes. So it's our duty that we should be sensitive to these kind of aspects. It includes healthcare as well and all that. Economic sustainability, again, ability of human communities around the world to maintain their independence and access to resources, basically to meet their needs, okay? So they should, we should have some kind of, because we know that economy is the backbone, right? So everybody, we have to design our system such that we have the capabilities to use that resources by spending some money, and everybody should be economically this one. So here we are talking about this social, environment and economic thing, and here is the sustainable, right? So basically we are trying to achieve all these three goals, right? And of course you might have already gone through it, that our United Nations, sorry for this. So United Nations development goals, they have been made, right? I think you might have already seen these 17 goals and all that, right? Basically what we want to say here, that we have a national kind of international type of robust framework, and it's only matter of that how can we follow those protocols and frameworks to achieve the goal of that one. But anyway, so that is sustainability. But then my topic today is about manufacturing, right? So I was told that not many of you are from manufacturing, right? So what is manufacturing? So manufacturing is basically we convert the raw materials to something of the use for the humans or other animals, okay? So raw materials are added or processed to make certain products, right? Now in doing so, this is one definition, but another thing is that you add value to some raw material. For example, you take a piece of say mild steel for 10 rupees, you make a nice knife out of it, you make it worth 200 rupees, right? So you are adding the value. So any process, this kind of approach is known as manufacturing, and we know that manufacturing is the backbone of any country, right? So in that context, if you see the evolution of manufacturing, so initially we were having big factories, we were having those kind of big businessmen who were using this manufacturing, and they would manufacture things, they will sell them in the market, and then obviously they will go to landfill here. So this landfill thing happened for a long year, but everything has a limit, right? You will be surprised that this approach has damaged the planet like anything, okay? So this is what was used to be done in traditional manufacturing, and unfortunately in countries like India, Pakistan, etc., still we are doing this thing. although world has gone to this place, right? But still we are doing this. If you have happened to go to, you know, sometime Delhi, right? Especially when you enter from this road, and there is some Karnal bypass, there you see the heaps of this garbage, right? So you will be surprised that the height of that garbage has gone beyond Qutub Minar, okay? So that is the state of affairs, where we are leading to, right? So this all because we were putting everything on the land, we use the product, we throw them, right? But then people started thinking about it. This was Japanese who thought that we should do at least something. At least we should reduce this landfills and garbage things. So they started thinking about reducing it, and that is what they named lean manufacturing. Lean manufacturing, basically, we are trying to use the just sufficient resources to produce the things, right? Number wise, quantity wise, everything. So lot of science behind this, a lot of theory behind this, but we are not going to go into that detail. So lean manufacturing is basically using the resources very, very diligently, okay, and in an economic, right quantities, right place, and so on. But then this comes with the green revolution, or what they call green manufacturing. This was the next in the chain, when people started not only reduce, let us try to reuse some of that part. So people have used the products, right? After that, can we reuse some of them, right? Or can we recycle some of them? Okay, so here you can see now 3 stems going: reduce, reuse, or recycle, right? So these 3 things, they constitute what we call green manufacturing. Now any process, of course, our primitive main processes are same. Still we are doing people making products on lathe and so on. Of course we have additive manufacturing now, but most by and large the processes are same, but we are trying to approach these kind of frameworks. Can we reuse some of that? Can we reduce it overall, and can we recycle some part of it into the system? Okay, so that is another approach which constitute what we call green manufacturing. But still we are not stopped here. Now people are thinking about, or in fact we have already, developed countries are already following this sustainable manufacturing, what they call. So sustainable manufacturing. Now in sustainable manufacturing, if you see, we have now reuse, reduce, recycle even. Now here we have redesign also, and recover also, of course, and remanufacture. Okay, so these kind of approaches, now we have 1, 2, 3, 4, 5, 6 approaches which constitute what we call sustainable manufacturing, right? So what is the overall objective? Overall objective is to achieve those 17 SDGs, what you call sustainable development goals, right? That is the ultimate aim. And if we follow these trends, we will be able to reach to the goals. And here is what I would tell you, all young engineers, maybe computer engineers or others. By the way, computer engineers have now big responsibility. We'll talk about that also. So whenever you develop any product, please think about the ecology, or these 3 pillars, right? How it is going to affect the environment, how it is going to affect the society, and what about economics? Because your owner, your employer will ask for money also. You can't ignore that, right? So all these 3 things you have to meet, and believe me, it's not difficult. Only thing is that you have to think innovative. Okay, and when I say innovative, the best thing which you should do is the observation. Okay, most of the inventions, they come from observation. Okay, so for example, my student saw, Dr. Malkeet Singh, he saw that while he was doing some, grinding, simple grinding, we know, all right? So these swap particles are flying into the air, right? But by chance there was some kind of obstacle. He thought, what will happen if I put mild steel in the trajectory of these swap particles when they are getting from the grinder? Then what he saw, the particles were sticking on that. Okay, and from there we developed this idea of what we call grind coating. And not only then, we extended it also to additive manufacturing as well. And surprisingly, when we patented it, it even got patented in US as well, not only in India, right? So sometimes very simple things, they give better results. The only thing is that you have to be observant. As I told you, my role here is not very academic. I want to be more philosopher also, because I see a lot of young students here. So maybe some of you will be triggered by these kind of thoughts. So that's what. Anyway, these are more details about green manufacturing. By and large, we have talked about it. Okay, so basically reduce, reuse, recycle, and remanufacturing, and so on. Okay, so if you can bring that kind of philosophy in your systems, you are good to go. So another thing within that proof itself is that there are 4 or 5 things which you should always take care of while designing your systems, or even using the current systems. One is the energy from the renewable resources. So long time, ever since the second industrial revolution, industry 2.0, we have been using electricity, and electricity, you know, from our coal, right? And mainly coal, still majorly we are getting it from coal, which is not a good choice. So can we replace, can we use some other renewable sources of energy? What are those? For example, solar energy. Okay, so can we use geothermal energy, solar energy, ocean energy, hydropower, and so on? What is geothermal, by the way? Anybody? Geothermal energy? किसी ने सुना है? From earth. Very good. So from earth we are getting. I have seen this practically happening in some University of Canada. They were heating their whole building through this geothermal energy, right? So simply you have to insert some pipes and so on, and you can get the heat of the earth, right, to heat the water and so on, right? Interesting things. Similarly, all this. So whenever you think about using some other sources of heat, energy. Energy efficiency is another thing. It is different from here, because here you want to bring or use as minimum as possible energy to do your work, right? अगर एक रूम में एक बल्ब से चल रहा है, you have to work with it. There's no fun in using 3-4, right? Similarly in industries, or similarly in case of your machining operations, when you do machining operation, you design it so well that you are doing it in a minimum time. If you are doing it minimum time, you are using minimum energy, and so on. So you bring the energy efficiency. Pollution reduction and removal, greenhouse reduction, recycling, all that, okay? Reduce and whatever we have already discussed. And natural resource conservation. We have to save our natural resources, right? So these are 4 or 5 approaches which you should keep in mind. Sustainable manufacturing, anyway, we have talked about it. So basically we have added these pre-manufacturing, manufacturing, use, and post-use. In this we have used this reduce, reuse, recycle, recover, redesign, and remanufacturing, right? All these things you have to keep. And by the way, it's not necessary that you achieve all the 6, right? But these should be over your mind whenever you design something, or while you are working on something. And surprisingly, not only industrial setups, but they work very well at home or in your institute as well. So whatever you do in your life. Well, so how do they do it? I think we have already understood this, right? So slightly, what is then you may be confused that we are talking about sustainable manufacturing and green manufacturing. The major change here, the difference here is that we know sustainable. Now in sustainable development or sustainable definition, we have now 3 pillars: environment, social, and the economic. So when you are taking care of all these 3, you are in a sustainable manufacturing mode. When you are doing only take care of the ecology or environment, you are in a green manufacturing mode. Okay, so that is a broader kind of difference. Now coming to Industry 4.0, here I want to give you one thing is clear, that to achieve these goals, what we need to do, we need to conserve energy, we need to reduce the waste, right? Energy efficiency, or what you call productivity, you have to increase, right? And operational efficiency you have to increase. And there comes this tool of I4, which can help us to achieve all these things, and hence the goals of your sustainable development. But before that, let us see how manufacturing evolved. You know, the first revolution of manufacturing was when, you know, even if we go to industry 0.0, what was 0.0? When everything was made with hand. Okay, somebody will use some stones and some, say, metal or something, and just no kind of specialized tools and nothing. Whole energy or manual effort is there, right? But then comes first what you call industrial revolution. So what was the key word here? The key word was here the water power, actually. So steam engines, right? We all know, right? Steam engines, when they came, they helped us. What? They helped us to run our machines as well, right? So steam engine is not only for running the trains, right? Whether it was even used for running our machines. So basically, it is giving us mechanical energy, right? So by converting the steam energy into even sometimes water itself, it was used to run the turbines, right? So that was the first thing, and that is where this 1760 to 1830. See this period, how the people have developed. And mind it, those who took the leverage of this revolution, they are still ahead of the world, right? And who are those guys? Mainly UK, European countries, US, and so on, right? So they have taken this edge. I don't think during this time India was somewhere there in this technology thing, right? So then came the second revolution came when? Anybody? What was the major thing here? Electricity, right? So then came the electricity. So when electricity came, we came up with some motors and all that. So now we can have these mass production flow lines and so on, right? And we also came up with some other gadgets which could be run with electrical energy, right? Again, great revolution. So this happened from up to 1914 period, so 1817 to this one. So this was the period when lot of innovations we saw. We saw steam mills, we see and so on, right? Then comes the third one. So third one was computer and automation. So it started somewhere last century, 1950s or something of that sort. And then again, what were the major thing? We digitized our machines, right? We digitized our machines. We made them automatic. The CNC machine, आप लोगों ने सुना होगा, computer numerical control, right? And those kind of inventions came, and our machines, they become automatic or semi-automatic. Okay, now you can program those machines and you can run them. And there was, of course, this internet and all that, which is also attributed to this period. Okay, so lot of automation and what do you call digitization, right? Then comes the fourth one. Fourth one is the one which we are now talking about. This is basically cyber physical systems. So basically it is developed from the previous 3.0 itself. So what was happening? So if you have to give some words to this, it is basically from digitization to digitalization, right? So what you have done here is that during 3.0, lot of data was created. Most of the machines were digitized, right? So we were producing lot of data. And let me tell you, we are very bad at collecting the data. Even when they were collecting data in third or second or first, by the way, these Western countries are very good in keeping the data. You will be surprised that Hitler used to have the data of those who were killed actually. Right? वो जिसको जितने मारता था उसका भी डाटा रखता था. What to say about nasty things? That was the record keeping, right? but that is sad, but I'm just talking about the positive things, that they always kept the data in place, whereas we are still not in a habit of keeping the data of our processes, right? आज भी आप किसी machine पे जाओगे, किसी industry में जाओगे, you will not find people having very nice data, but they were collecting the data without knowing what they can do with that. Especially here, a lot of data was created by computers because machines were having their own memories and so on. So from there itself, this gave rise to this one. They thought what should be done with the data, and from the data something emerged which we call machine learning and AI, right? Because when you have a lot of data about some behavior, so you can always manipulate it mathematically, right? And do some sensible kind of conclusions from that, okay? Why it was not earlier possible? Here it was possible because now we are having strong computers, right? So strong computers, big data, now we can make sensible conclusion out of this. And that is where this fourth industrial revolution came up, and it came up with a lot of advantages. We'll touch upon some of them. So not only that, we were having internet also, so you can connect your machines, your physical and cyber world through cloud, okay? And distances have now melted, borders have now melted, at least in Industry 4.0 scenarios. You may have one industry here, one in Europe. You can interact real time, okay? Because you can now transfer the data through cyber systems and to the other systems, right? So there is now real-time kind of communication. So cyber plus physical world, both have been now clubbed, and that is what we call Industry 4.0, okay? Well, so let me tell you why it is so much important, why we are talking about Industry 4.0 so much. Okay, in fact there is now people are talking about 5.0 also. By the way, what is the difference between 4. and 5.0? किसी को पता है? Anybody? 5.0 भी कह रहे हैं ना आजकल. People are crazy about floating new and new terms. Some people are in a rush to say 6.0 also, but at least 5.0, this term has become slightly formalized. Let me tell you what happened. In Industry 4.0, they put all the emphasis to make the machines automatic, even autonomous. Automatic से आगे क्या है? Autonomous. Okay? Autonomy क्या है? When in automatic you have to program the machine and it will do your job, right? But autonomous, it can now take decisions as well, what you call AI and machine learning and all that, right? But in 4.0 they forget the interaction between man and the machine, okay? So then they thought that how it will happen if there are no man, okay? So we have to be sensitive to this kind of relation, machine and man collaboration. So that is where 5.0 is now mainly talking about, that how the human and these advanced machines interact with each other or collaborate with each other. Because in the same setup, you are also there and you have a robot which is intelligent than you, and both of you have to work jointly, right? So a lot of issues will be there, right? How to take care of security and other things. Suppose you are handling one big piece, on one side there is a robot, other side you are the person. You may be naughty, he may not be, something of that. So how all these things will be taken care in the system and so on. So that is where 4.0. But anyway, it hardly matters whether it is 4.0 or 5.0. The main problem here is that problem, or you can say challenge for us to catch, is that this Industry 4.0 is unique in 3 aspects. क्योंकि some people say ना, पहले भी तो हुए थे इंडस्ट्रियल रेवोल्यूशन, क्या हो गया? What is so worried about it? पहले भी हम 1.0 to 2 and 3 गए. What was the big deal, right? So the deal here is that this revolution is taking place at a very high pace, okay? Things are changing very fastly. Every year you can see some changes, right? This is one, that accelerated exponential expansion of these technologies, cyber physical systems. It is Second thing is breadth and the depth. Integrates multiple technologies that are catalyzing significant changes in the economy, business and society. So it can work, it can collaborate, it can join, say, supply chains, your machines and everything. It can be connected, right? So depth and breadth is very, very much high. So, and third one is systems impact. So this is going to affect the whole systemic level change. Means हमारा सोचने का पैराडाइम ही शिफ्ट हो गया है, जब हो जाएगा बहुत जल्दी से, right? Manufacturing, the way we were thinking earlier, is entirely going to change. Not only manufacturing, but the whole thing, whole businesses, whole thought process, whole system of doing the work is going to change. Okay, that is what is worrisome, and that is where lot of discussion is there. Maybe I'll touch some of those points here as we progress further. So what are these 4 points? If now 4 or 5 things you have to identify, what is so unique and what has resulted into what we call Industry 4.0. So there are these 4-5 points. One is connectivity, data and computational power, right? So now we can connect the machines. Okay, now machine can be connected to its workpieces. Machine can now interact with its workpiece, that I am now free, you come, right? How it will do? We will use some sensors, right? So basically कर क्या रहे हैं हम? We are basically making our machines autonomous. And how we can make machines autonomous? If we can give them these 4 or 5 senses which persons have. What we have, we can touch, feel and all that, right? And of course we have the brain to make certain calculations or decisions. So same thing, if you can put in a machine, obviously your machines will become autonomous, right? So, and that you are basically now, for doing that, you have to connect the machines, you have to have a data which we already have, and this is new thing that we have now, computational power also. Okay, although we were having some models, right? For example, nowadays we talk about prescriptive analytics. Already we have those simulation techniques. We already have that simplex method. But what was the problem? Earlier the simplex method could be, say, manually applied to, say, 5, 6, 7 constraints. But now you can apply it to 1000 or 2000 constraints as well, right? So that computational power is one of the foundation. Another is analytics and intelligence, so which is coming from this machine learning and artificial intelligence, right? So then human machine interaction. So we have now virtual reality and augmented reality, robotics, automation, autonomous guided vehicles and all that. Okay, so now we have all this in place, and advanced engineering. So of course one may always say that everything is now facilitated, but your machines are still age old, right? And heavy and all that. So what there, this revolutionary thing has come, which we call additive manufacturing. What is additive manufacturing? So anybody? Additive manufacturing क्या है? And even mechanical engineers तो होने चाहिए, but दूसरों को पता होना चाहिए इसके बारे में, right? You may not be knowing, but you know 3D printing, right? Now everybody will say you know it, right? So 3D printing is one type of additive manufacturing. So additive manufacturing is any technology where we are building the part layer by layer. Okay? So अगर मुझे ये बनाना है, so I will make it by layer process. That's it. Okay? Now there are different types of technologies. If time permitted, I will name them also. But that is what, right? So layer by layer you can produce. 3D printing is one type of additive manufacturing, right? And this name has been more popular than additive manufacturing because that was the first process invented by these US guys, right? So basically idea वहीं से आया था. कहाँ से? 2D printing से. So in 2D prints you are dispersing some ink, right? And it is getting solidified on the paper, right? Now they thought, what would happen if we keep on giving, instead of ink I give the binder, and if I expose this binder or expose a layer of powder to this binder and dispense the binder on it, what will happen? Wherever you put the binder, the metal particles will stick to each other and you produce the first layer, right? You again put another layer, you again put more ink or what you call binder, you develop another. So layer by layer you are building the part, right? So that was 3D printing, but then later on we come across several technologies and still this area is open. For example, Malkeet and we develop another technique, but you can also develop any technique. Any technique where you keep on making the parts by adding layer by layer, right? So you think how these layers can be added, okay? And you can then do something very important. This just to emphasize why it is important. See, those companies who are thinking about this Industry 4.0 are expecting this much kind of positive cash flow, 122%, right? So this kind of economic kind of benefits are expected to flow through these technologies, right? And of course those who are not adopting, they are going to be at loss, obviously. Okay, this could be interesting. So what is the impact on the economy? One thing is that demand for physical and manual skills, repetitive tasks will be reduced. Okay, obviously. I want to discuss the role of these this I4 on our job scenario also. That could be interesting for us. Okay, I have few slides on that. Okay, so you can see that here, there is a decline in certain skills, but there is demand for complex cognitive skills by 33%. Okay, so you have to see this also. Demand for technological skills such as coding will rise from 50%, right? Then social and emotional skills, this is also going to be rise. So these kind of experts will bloom in the future. Why? Because the social and emotional skills will be needed. Why? Because you will be working with robots, right? Right now you are working with human beings. Human beings can kind of interact, they can share their emotions and so on. But what would happen if you are being deputed in an industry where 10 robots are there and you alone is there on that shop floor, right? Those kind of challenges will happen, but accordingly, what I want to say there is that you have to prepare yourself for these challenges. Okay. Smart manufacturing is another term, just for your knowledge. Industry 4.0 and smart manufacturing, they are used interchangeably, these two terms. Okay. In fact, US people, they don't want to call it Industry 4.0, they want to call it smart manufacturing, right? And where Germany or Europe, they want to use this term Industry 4.0, right? We are somewhere in between and we have to understand both. But on a broader level, they are same. But if we go very deeply, then smart manufacturing is basically limited to our industry level itself, within the factory or within the factory. Whereas Industry 4.0 is much wider, right? Industry 4.0 practices are beyond the factory of boundaries of the factory. It even goes from, say, supply chains, right? Raw materials, from where they are coming, they are being then dispersed and so on. And I mean, the umbrella of Industry 4.0 is much beyond the factory level. Okay, so it goes up to global level. Okay, and not only manufacturing, Industry 4.0 covers other businesses also, right? From finances and your shipping and whatnot. But smart manufacturing is core for our manufacturing engineers. Here we are more talking about core manufacturing, and we are talking about interconnected and collaborative machines which are intelligent and so on. But core technologies are same. Anyway, let us touch upon some of the important things here. So what are the major technologies which enable us to be compatible with Industry 4.0, right? I hope you have not discussed it. If you have discussed, we can quickly go through this. So there are kind of, some core technologies which make or which are enablers of industry 4.0, what do you call, right? So what are those? We have this big data analytics. Okay, so we have now algorithms which can process very big data. Okay, we have this 3D printing, we just talked about it, additive manufacturing, and we have this collaborative robots, okay, we call cobots, okay, which can collaborate with human beings and so on. And we have enterprise resource planning, ERP systems, where each and every activity in the enterprise level could be monitored and controlled. Industrial Internet of Things. Industrial Internet of Things is also very, very important, and one of the major, this is basically every system will have its own IP system. You can imagine it like this. Jobs and everything, it will have its own IP address, as well as these networks will keep on collecting data from sensors. Okay, so sensors and those algorithms, they make what you call industrial Internet of Things. Okay, so that is their edge computing, and we have cloud computing, right? So cloud computing is something which is at bigger level, but edge computing is also very important. Here you can do some analytics or some control at the machine level itself. Okay, some kind of computing you can do at the machine level. Okay, so here you need not to collaborate through clouds and so on. So it's like that way in a simple language. Digital twins, another very, very important thing, that digital twins kya hai? So it's basically digital replica of the machines. Okay, so what we can do, for example, you are running, say, lathe. Okay, you are making some job and all that. What you can do, you can capture the data. Okay, data means you can capture, say, RPM, you can capture surface roughness, you can choose speed of cut and so on. How do you will capture that data? With sensors, right? And then some processing. Now based on that, you can prepare a digital replica of your machine. Okay, so that digital replica will be exact real-time monitoring of that one thing. Another thing is you can play with the parameters in the digital replica. Okay, suppose you want to study some variations and so on, so that digital replica can be used for designing new processes and so on. Okay, so basically that kind of thing. So again, very important thing. And of course virtual and augmented reality and all that, we have now very kind of advanced gadgets, okay, which can be used. Augmented reality is more important here. For example, in industrial setup, you wear those gadgets and you can then maneuver or find the things actually, or you can even imagine and so on. So all these technologies are backbone behind this what you call industry 4.0. We'll skip this whole things. I can leave these things for you. If those, of course, there is a lot of people. Rockwell Automation report. This is one case study where they have seen. This is important. I want to tell you that how industry is using. Industry 4.0 practices are being used or adopted by the industry, right? So this is a very recent survey in 2025 itself. So they say the next 12 months itself, 50% of the companies are using AI for their quality control, 49% for cybersecurity. By the way, cybersecurity is biggest problem. When we talk about the challenges to Industry 4.0 or smart manufacturing, the biggest challenge is cybersecurity. What is that? We all know, right? Breach of data, okay, or theft of your data. And industries are very particular about their products, their designs and so on, right? So they can't afford to, a breach of their data. So that is one thing. And those, especially those computer engineers sitting here, if you become an expert in cybersecurity, nothing like that. You can earn millions. Okay, so cybersecurity, people are process optimization. People are trying to use 42 industries in this survey. They are trying to use this AI for process optimization, and robotics, and then logistics. Logistics mean supply chains and all that. Okay, so of course 55% state that improving efficiencies is the key driver to pursue sustainability. Okay, so basically what does it mean? So basically they say that if AI can be used and if we can increase the efficiency of their systems, it will automatically come with sustainability as well. Okay, so that is what is the kind of quick comment on that. And of course these industries are using still, if you ask me, the most frequent use of Industry 4.0 practices is mainly in quality control. Okay, another is predictive maintenance. Okay, so we have few examples on that, that sort of things. Okay, so then we have of course these are the obstacles. I'll come to that if need be. So this is something for you guys here. See, the common threat to us or insecurity to us is that if the Industry 4.0 will come, what is going to happen with the jobs? Okay, is it that all the jobs will be done by our robotics or the autonomous systems? Do we have some space? But you will be surprised that we will need more skilled people. Okay, so that is a survey which is the same survey which is done by Rockwell Automation company. So they say 83% analytical thinking plus communication and teamwork are the most important skills when recruiting the next generation people, right? Look at this, analytical thinking and communication and teamwork. Okay, and let me be very frank, we are very bad in teamwork, especially as a nation. We have to improve on it, right? And of course communication is another thing, and here we are talking about communication, your soft skills and all that. Not only that, but even IT communication and so on. Okay, so anyway, this is how industries are going to spend. So industries are going to spend a lot of money either in AI, ML, or generative AI and causal AI. What is generative AI? So, and causal AI क्या है? So AI where we can, AI which answers why also, right? Why also. It can give you some data, but it can also explain you why something is happening, why my surface roughness is becoming more or less, right? Those kind of things. This one. So these are few examples. I think you all understand, right? Once we have this is a one example of automated maintenance, right? So here this is one example of adoption of I 4.0. So what basically we were telling, that we have connected machines. So these machines, we will have some sensors on it. Okay, and these sensors will collect the real-time data here. Okay, and that data will be processed. So we have this machine learning module to develop models from this. Okay, and then this module, so basically real-time monitoring we are doing it. So we are seeing this, and if there is some kind of anomaly, you can then predict it, and then you can take suitable actions. Okay, even it can of course this is one level, but now people are thinking here we have automated maintenance. Even we have now systems where we have autonomous maintenance as well. Okay, so in many cases machines will be able to do not only error detection but the correction as well, right? So there will be different possibilities and so on. So this one, but this is one of the major applications right now, predictive maintenance. What is predictive maintenance? Anybody? Predictive, as we know, predict, can we predict something, right? So see what happens in industrial setups. Whenever there is a breakdown in any machine, it costs us a lot of money, right? Because your whole supply chain is closed, right? Your workers are idle, they are not doing anything, and you have to spend money to repair the machine and so on. And moreover, this has happened all of a sudden. You could not plan it well, so there will be delay in supply of repairs and everything, right? And spares. So what people are now using, this is the most common application. Even in India, several companies are trying to use this predictive maintenance. So basically they are getting data, just I showed you in the picture. So they are basically training their models and seeing if the machine is going, for example, the vibration is within control and temperature of the machine is within the control signal is coming. So if they are compared with the reference signals, so everything is going fine, this is a fine thing. But not only that, from that data, your protocols can even predict the future also, right? Based on the previous failures. Of course, you will need a lot of data for this model. So your model will have a lot of data, past data, that after how many hours of working machine was failed or something, right? At what temperature it was failing, and after how much time that temperature achieved and then failed. All that data, from all that data, your model will be able to predict beforehand that your machine is going to, say today is say Tuesday, it is going to fail on say Sunday. So when you have this kind of prediction beforehand, obviously you will be ready as soon as the failure is or maintenance is scheduled. You know that Sunday I have to do this, so you will order everything and you will put it there and you will get it done. So that is the biggest advantage here, which people are doing. So this is in fact this is one of the application. In fact, now people are moving to the next stage. See, you are computer engineers, so data analytics is further, there are 4 modules in that, right? So what is the first one? Descriptive analytics, right? Have you heard about this descriptive analytics? किसी ने सुना? कंप्यूटर वाले हैं यहाँ पे? हाँ, तो सुना है descriptive? हाँ, descriptive, that what is the current state, right? Then diagnostics भी है, क्या हुआ? उसमें why it has happened. Okay, descriptive, what has happened. Diagnostic analytics, where we see why it happened, right? Then predictive, when it will happen, right? And now 4th stage is prescriptive. जैसे डॉक्टर प्रिस्क्राइब करता है, the same way your modules will prescribe you what action should be taken, right? So these are 4 stages of your data analytics. Okay, so we have diagnostics, and before that we have descriptive, and mind it, all of you, even mechanical engineers, they know about descriptive analytics. Something, I just want to trigger you that you should also read some basic books on data analytics and all that. Not that you are not computer engineers, right? And you will be surprised that you will be able to understand those terms. At certain locations the names are given some fancy names, but let me tell you, if you know the statistics well, that mean, medium, average and all that, right, standard deviation and all that, if you know that, and if you know how to plot data, that means you already know the descriptive analytics. In descriptive analytics, it's only that you have to take the data, you have to represent in some tangible form or understandable form. Understand करने के लिए हम क्या करते थे? वही मीन, मीडियन, मोड निकालते थे, स्टैंडर्ड डेविएशन, राइट? वही तो निकालते हैं. और क्या करते हैं? We plot the data, right? Now here, instead of 2-3 dimensions, we have now several dimensions. So very interesting things you can study, but not very tough, let me tell you. Then the second, diagnostic analytics, and you will be surprised there mechanical engineers tools are being used. Diagnostics means why. When you say why, one of the techniques mechanical engineers use is root cause analysis. वो भी तो why होता है, why it is happening. So we do root cause analysis, we use those fishbone diagrams and all that, right? So that is diagnostics. We cause and effect relationships, that all we know in industrial engineering, right? So you will be surprised that several things are there already, which are now put under data analytics under the name of certain other designations or something like that. But it's not tough. What I want to say here is, then the third one is predictive analytics. There you have to do some effort, right? So in predictive analytics, basically क्या कर रहे हैं? At lower level we know what they are doing. Basically they are doing regression analysis. वो जो हम करते नहीं है कि हमारे पास कुछ डाटा है 1 महीने के लिए है, तो हम उसको 10 महीनों के लिए एक्सप्लोइट कर दें, एक्सट्रापोलेट, और इसका लिए है अगर हमारे पास फर्स्ट 15th 30th 45 डेज का है, तो इन बिटवीन सम डेज का हम निकाल सकते हैं, राइट? सो दैट इज प्रेडिक्टिव. यू कैन प्रेडिक्ट फ्रॉम व्हाट दे कॉल रिग्रेशन टास्क, यही कहते हो ना आप लोग. दूसरा क्या होता है? क्लासिफिकेशन. क्लासिफिकेशन हमें करना है, दिस इज गुड, दिस इज बैड, right? Can our module pick that on a flow line the part is being sent? So your sensors have to tell whether it is a healthy part or bad or damaged part, right? So in that case it's a classification task, right? So your system will tell us whether it's bad or acceptable or not acceptable and so on, right? So similarly, so then in the prescriptive where we recommend the actions, right? There again, mechanical engineers, you have, if you are taking this operations research, major part of operations research is covered in this one also, what do you call prescriptive, right? जैसे हम simplex method करते थे. In simplex method what you are doing, you are trying to allocate limited resources to certain competing activities. यही करते थे ना. So this is nothing but prescriptive. You are prescribing something, that I have this much machine time, I want to give 3 hours to this A machine, 2 to this one, keeping care of the constraints. So that's what is prescriptive. Of course new algorithms have also been developed in between, of course there are a lot, but what I want to trigger here, you guys, young guys, that please, अगर आपको डाटा एनालिटिक्स की सिंपल बुक लेके पढ़ना शुरू करोगे, you will enjoy it and you will be happy to know that it is not very difficult task to learn it. Okay, by the way, this Schneider is the German company. They are using this industry 4.0 like anything, right? So they have got lot of benefits. So what they have done, I'll just show you some of the So they fix these targets, okay? So whenever you think about applying your industry 4.0 strategies, or in fact कोई भी strategy अगर आप अपने system में लाते हो, तो सबसे पहले आप क्या करते हो? You define the problem, then you select the targets, right? So for example, this industry in this study, they thought that we will reduce the energy consumption, right? And they say we will use IoT sensors and digital energy management systems. Okay, and they say we will also lower the carbon emissions and we will minimize the water usage and we will cut the waste. And for this they have used some kind of one of those technology which I showed you, 10 technologies, right, over there, IoT and data analytics and AI and all ML. So in achieving these goals, so they used these technologies, right? See, one of the key things which I have understood so far is the real-time monitoring. See, if we can observe any system in real time, no, lot of benefits come, you know. So one part is that you can take corrective actions and all that, but another thing is you could be a future ready as well. Okay, for example, अगर हम एक simple I forget the name of that city in some country where they are showing on several roundabouts that real-time level of water in their country, real-time water level, which is dipping or something, whatever, right? Now when people are seeing every day that कल मैंने देखा था 700 मीटर चला गया, आज 701 हो गया, right? So that triggers you a lot, okay, for improvements, for introspection and so on. So is the case in manufacturing setup also, right? Everything is monitored, and from there you can do some kind of strategies, okay? So that is one in bit. So what benefit they have got? See here. So when they say productivity improvements, कितनी हुई उसकी? In 2017 it was 100 and now it is this one. So earlier, so this with AI and AR, smart manufacturing, they could improve their manufacturing efficiency index from 100 to 160. Look at this. In how many years? Probably in 70 to 24, almost 7-8 years. So this is what. Another thing, energy saving. Look at this. So energy saving, reduction percentage 25% energy use, CO2 emissions again 25%, and 64% water consumption. Look at this, 64% water consumption, and they are doing in France, right, where water is not a big deal, but here we never think about these things, right? So this one, you can see the benefits, and you can see here also, what is this? Relative performance index, that has also field failures have decreased 45%, 48%, and this is what repair time has also gone to 20% less. So these kind of benefits are obvious, okay, and they are implementing this thing in their this one, all those some of those pillars, 10 pillars which we just gone through, right? You can see this video also. I can leave these slides with you if you want, for you to digest later on. Now this is employment scenarios. See, we will spend 2-3 minutes on this, and now why I want to say that, whenever new technology comes, people are afraid, okay? Even when this industry 4.30 also, when it was on the verge, people were worried. This economist John, he said that due to our discovery of means of economizing the use of labor, overturning the pace at which we can find new uses for the labor. So he was saying that there will be a lot of unemployment as soon as the CNC machines and robotics it came, okay? But nothing happened actually. However, this proved to be wrong, okay? But this time people are worried. Why they are worried? Basically due to these 3 aspects: velocity, breadth and depth, and systemic impact. I told you three dimensions of industry 4.0, right? So they are basically triggering and raising our worries. But there is nothing to worry, because this was written in 2016, but later on we have seen some positive things, okay? So one thing is, all are agreeing that certainty is there, that new technologies will dramatically change the nature of work across all industries and occupations. Nature of work is going to change, okay? And uncertainty hai ki kitna, how much, okay? How much automation is there? Will it be going to be 100%? All the industries are going to be industry 4.0 compatible, or what? And how much time it will take, how far it will go, and so on. These are some of the questions, okay? But main thing is that history is showing that outcomes is somewhere in between. We are not going to face so much unemployment. Why? Because there will be change in the nature of jobs, one thing. Second thing is that humans are hungry. Humans are always, their demands are unending, okay? So one of the philosophies is that humans industry 4.0 से भी satisfy नहीं होने वाले. They will ask more and more. So that is why we need not to worry too much about employment scenarios. But one thing is going to happen is that the nature of jobs will change, businesses will change. And one of the salient examples of that is this. Look at this. With Industry 4.0, new job ecosystems will develop. For example, this is a beautiful example that when Steve Jobs opened this app market, right, in 2008, right? So he opened this for app people to develop apps and so on, right? At that point of time, and in 7 years only, the global business which was coming from app economy was $100 billion, right? Which surpassed the film industry. Look at this. Film industry कितने साल पुरानी है? 100 years. So although we see lot of unemployment in film industry, maybe our theaters are closed and all, so many things. When theaters are closed, some people who are working there are closed and so on. But at the same time, we have got opportunity for our younger generations that they can now start some new businesses. The lesson here is that you have to now think about what should be done, what is your niche area, right, and where the market is going. And that is where I tell you, if I don't take me wrong, if I have to compare students from some better institutions and the other institutions, the major difference, or you call it like this, what is the difference between a successful student and an average student? The only difference is, it's not the mental level. Let me tell you, listen carefully. It is about your awareness. It is about your awareness. How aware you are about your future, about your future goals, about your opportunities, right? What they call SWOT analysis: strength, weakness, opportunities, and threat analysis. And that is where, if you go to IIT students, most of them, they know what they will do, right? And हमारे यहाँ क्या है, बहुत सारे स्टूडेंट कहते हैं हाँ सर मैं बीटेक करके कनाडा जाऊँगा. कनाडा क्या करना है, we don't know. If he says I will go to Canada and I will do this is agreeable, right? But if he says Canada जाऊँगा, that's not a goal, right? So that way. Another thing is, you should know, and they know what they should prepare for. After 4-5 years, what will be in demand? वो कैसे आएगा? If you understand these kind of lectures, or you read the literature from yours, right? So this is especially for you young people here. See what kind of skills are on rise. If you see here, creative thinking is the top, right? Creative thinking is that, and the manual things are at the end. There will be now no jobs that you go to machine and do some machining or something of that sort, okay? So analytical thinking, very good mathematics, data analytics and all that, okay? Technological literacy, curiosity and lifelong learning, resilience, flexible. So these kind of, you can see this nice survey here, and accordingly you can think about choosing your careers. It's not that you have to change your degree. Your degree is good. In fact, let me tell you that those who are doing engineering in core subjects, they are well placed. If I talk about long future, right? Not that you get the initial package of this, right? Long term. Provided you supplement your knowledge with I4.0 or 5.0, some core skills, not all those 10 pillars, maybe 1 or 2 pillars, you be and you should know how I can use, say, AI in my mechanical engineering. How can I use AI in my electrical engineering, and so on. If that is the combination, that is the key to success. Not that only you learn AI, but you don't know where to implement this AI. So I used to say that those core engineers, they have edge. They have edge that they have the technical knowledge already. Now they can put the icing on the cake in the form of some of these tools, maybe AI, data analytics, or something of that sort. And then if they say in the future that, in the interview that, okay, I'm going to use AI protocol for measuring or monitoring my machining process and so on, so that will be the great thing to do. So that is the way. Else, for computer engineers, the lesson is that they should collaborate with the other engineers, mechanical engineers, electrical engineers, do some projects, see where you can apply your knowledge, right? That will be the perfect combination. I think that's all. Yeah, I mean, once I start, professor, then they don't stop so easily, but I think you guys have to go on a bus, right? You have a 3:30 bus. Last thing is that please feel free to contact me if you want to do some kind of internship or something, right? आप लोग देखते रहते हो IITs वगैरह में, do some internship, right? देखो, I don't know what other professors, but when I see my emails, I get lot of emails outside Punjab for internship requests from BTech people, right? But from Punjab I get minimal. कभी कोई बार कोई एक आधा बच्चा लिखता है कि I want to do internship in your lab. So lesson, you should also be active, right? If there are some good institutions in your vacations, go to those institutions, do some internships and learn some lessons. Thank you very much. I hope it makes sense.